Assalamu alaikum everyone. Today we are going to conduct lecture number 24 of this online course Microprocessor and Assami language, and today we are going to cover about shift instructions. So let's proceed to our topic. Okay, today we are going to talk about shift instructions, and in this slide we are going to cover two different instructions that we will be practicing in this lecture. So very first instruction is shift arithmetic left, and the second instruction, which is also included in this table, is shift logical left. This SAL is shift arithmetic left, and this SHL is shift logical left. So these are two different commands, and both eventually works for similar way. That is why they are combined in this table, and the format is also similar. SAL, which is shift arithmetic left. D is a destination bit, or sorry, destination register, or the destination operand, and the count is one of the input which is required in this instruction. And the similar format is for shift logical left, that is SHL. D, which is destination operand, comma count, which is an integral component of this instruction. So let's proceed to the operation. What is written here? Shift the D, which is this destination, left. Okay, we have to shift the D destination operand towards left, and by the number of bits. So how many bits you have to shift? It is in number of bits equal to which is given in the count. So for example, if count is 2, so you have to shift 2 bits left. Okay, if count is 3, you have to shift 3 bits to the left. Okay, and what will happen if we are shifting our D operand towards left? So definitely there will be some vacant places creating in the right side. So what will happen? You have to fill with them 0. Okay, so that's the point, that is the operation, and we're gonna see these things in detail when we are going to practice it in emulator. Okay, one thing which is important, we need to consider that there are some flags which are going to affect and which are mentioned here. Some flags which are undefined, and some are undefined in certain conditions. So we will be looking in these facts in emulator as well. Okay, next two instructions we are going to cover is shift logical right, and shift arithmetic right. Remember, in case of left, these two shifts, logical and arithmetic, were similar. That's why we merged them in one row of this table. But now we are going to separate them because they do have different meanings, and their purpose seems to be almost similar. So let's see. Okay, SHR means shift logical right, SAR means shift arithmetic right. Okay, format is quite similar what we see in shift left arithmetic and shift left logical. So shift SHR, shift logical right. D is for destination operand. Count is an integral input, which I explain you. So what does it operation says? You have to shift the D towards right, and by the number of bits equal to the count. That means whatever the number given in the count, you have to shift by that equal number of bits towards the right. Okay, that means that's one thing, and you have to fill the vacated bits on the left. Of course, if you are shifting towards the right, there will be some space created on the left, and that space created on the left should be filled with the 0, and this is the logical right. Okay, this is given in the logical right. But where comes to the different where we come to the difference in shift arithmetic right, you have to shift towards the right. That is the same concept, and equal to the amount which is given in the count. That is also similar concept. But what you will do with the vacated bits on the left, so this time you are not going to fill with them 0. This time rather you are going to fill them with the most significant bit of original D. Okay, that is something which is difference here. I hope this point is clear, and we are going to further explore this point, and we are going to cover why this difference comes into the picture. So let's proceed to the emulator practice. I hope this point is clear at this point. Okay, in this slide we are going to talk about shift logical left, that is SHL. Let's say we move a number, move AX, let's say we move 02 in AX, and then we want to move we want to shift it AX by uh, 1 bit. Okay, so let's say 01 hex. Okay, so let's see what is going to happen. Okay, before doing it using emulator, we can perform our uh, calculation manually, and when we going to perform manual calculation, what we see, AX value is currently 02 hex, which is equals to 0000 okay, and that is 0 0 and 10. That's it. That means, and when we are going to shift it logically by 1 unit, that means what is going to happen, 0 0 0 0 0 0 0 0 1 0, and this left position, this rightmost bit is remaining, so we have to put it 0, and when we are going to run it, let's see will it be same or not, and that would be equal to what, 04 hex. Okay, so let's see, single step, okay, 04, yes. So that is the meaning of shifting logically towards left. So whenever you are going to shift a number logically on left, you are going to multiply it by 2 power the number of bits you are shifting. For example, number was 2, so we are multiplying it 2 power, because we shifted 1 bit, so 2 power 1, that would become 4, and that is the result. Okay, that means we are multiplying it. Okay, okay, let's check one more time. Let's say we have value of 16 in decimal, so that would be what, that would become 10 in, or we can take simple value, let's say 04 is here, and we want to multiply it with, we want to shift it 2 units, so number is 4, right, number is 4, and we are going to multiply it 2 power 2, that means result should be what, 4 times 4 would be equal to 16, and that would be 10 in hex. Okay, so let's see, so we gonna do 04 would be what, 04 would be 100, and when we are going to shift it by 2 unit, that would 1 come here, and rest of the thing will be 0, so that is of course 10 in hex, and furthermore we can verify it using this emulator. Let's emulate this program, 04 and 10x. I hope this point is clear. There is a glitch. If you want to get rid of that glitch, you can just move that count in any register. Let's say we move this count CL comma 02 hex, and then we can use that register just to avoid that glitch. So let's say 04 02 is in CX or CL, which is a count, and that is the result, 10. I hope this point is clear. Okay, in this slide we are going to deal with arithmetic left or shift arithmetic left. Here we need to know what is difference between shifting arithmetically or shifting logically. Whenever we discuss shifting logically, then we are talking about shifting the numbers, or we are dealing with numbers which are unsigned, and when we deal with arithmetic shifting, then we are basically applying this operation on signed numbers. So this time we are going to deal with move a signed number. Let's say we are dealing with -02 in decimal, or that would be what, FFE hex in hexadecimal. So I hope this point is clear, and this is just 2's complement form of negative number. just to tell you, that is -2 in decimal. Okay, and then we have to apply count. So let's say move, we are using CL as a count register, so let's say our count is 02. Okay, hex, and then we will be applying our shifting arithmetic left, AX comma CL. CL is our count, so AX is our destination. Okay, let's simulate it. Okay, perfect. Okay, before we go in step-by-step emulation of this program, I want to just explain using an Excel sheet because I have designed it for you. Okay, this is -2, and we are going to shift it. We are going to shift it towards left. Okay, so one can clearly see that this column, this C column indicates what? This C column indicates binary numbers. So that is what happening, shifting towards right. But remember, we are shifting sign numbers because this most significant bit is 1, which means we are dealing with sign numbers. So -2, whenever we multiplied it, count is equal to 2 power 1, so that would become -4. If we multiplied by 2 power 2, that would become -8, because 2 power 2 is equal to 4. 4 2 is 4 into -2 would become -8. So this is the hexadecimal decimation it shows. So here count is, in this example, count is 2, so we expect result F8. So let's see. Single step, FE is loaded, 02 is loaded, and count. Look, F8 is here. I hope this point is clear. Just to take one more example, let's say we use here some other number. For example, we use -22, and just to clarify, let's say we are -22. Okay, -22, and we will be using count. 2 power 2 is equal to 4, so that should be -88, right? 22 times 4 should be -88, and that should be FA8, and -22 is FEA, right? This is -22, which is FEA, and -88 is FA8. So let's see, is it going to happen or not? So we will be changing it. FEA, this is -2, and we expect what we are expecting, FA8. Okay, FA8 in result. So let's see whether this count is working or not, or whether this shifting is working or not. So we're gonna emulate it. Single step, count is loaded, and look, FA8. I hope this point is clear. You can use any count whenever you are dealing with sign numbers. You have to use this arithmetic left, and whenever you are using unsigned number, then you have to use it logical left. Okay, I hope this point is clear. Okay, in this slide we are going to discuss about shift logical right. So we have to learn the difference between right and left shifting. We have already gone through with left shifting with arithmetic and logical difference. So shifting left means we are multiplying the numbers, and shifting logically means we are multiplying the number unsigned numbers. Okay, and shifting arithmetic left means we are multiplying the numbers of signed numbers, and the multiplication factor is 2 power the count. Whatever the value of the count, you have to raise that into 2 power, right? So let's see what we are going to do in right shifting. So shifting right means is totally opposite to shifting left, and since we were multiplying the number in left, so we are going to divide the number in shifting right. So let's see what is going to happen. Let's say we have a number move, and we are using some okay, 220. Okay, move AX 20 decimal, and remember 20 decimal would be equal to what? 1/4 in hex. Okay, I hope this point is clear to everyone. It is 1/4 in hex, and then we divided by 4, so we will be using count equal to what? Equal to 2, because 2 power 2 equal to 4. So 2 power 2 is 202 hex. Okay, and now we are going to shift logical right AX with CL. So 20 divided by 4 would become 5. Okay, because 20 is our number and 2 power 2 is the count. That means 2 power 2 is count. That means 20 divided by 4, which is equals to 5. So let's see what is going to our result. So we will be emulating. Okay, where did we make mistake? Okay, this equation, this is not the part of the program, so let me comment it. Yes, now we will be emulating it. Okay, everything is okay now. 14, which is 20 hex, 20 in decimal, 02, which is count, and 05. I hope this point is clear to everyone. Okay, we can test one more example. For example, we this time divide 40 would become what? It would become 28 in hex, right? And we are dividing 40 by 8. So let's say we 2 power 3 would be counted, because count value should be 3. So 40 divided by 2 power 3, which is 40 divided by 8, and 40 divided by 8 should be what? 05. So let's check this value here. 28, which is equal to 40 in decimal, 03, which is count value, so 2 power 3 should become 8, and 05 is our result. I hope this point is clear to everyone. Okay, in this slide we are performing shift arithmetic right. So we will be dealing with sign numbers. Let's say we are dealing with minus 40. Let's convert that number into hexadecimal, and I can do it using this sheet. So minus 40 is equal to what? FT8, or since we are writing it in 16 bits, so FT8 hex, right? And I can actually okay, this is just comment. So I'm going to load this program, move AX comma 0 FD8 hex, and now let's say we divide it by 2 power 3. So move CL is equal to 03. So minus 40 divided by 2 power 3 would become minus 40 divided by 8, that would become minus 5. So let's see how we will proceeding this using this shift arithmetic right. So shift arithmetic right AX comma CL will be used as a count. Okay, before we go and emulate this program, we have to do it manually. So let's say FFD8, right? And I will be doing it manually. So 4 times 1, then F101 and 100, right? That is FFD8, and we are shifting towards right, so this one come up here, right? This 10 will be here, 101. From where that came? From this position. I hope you know it. 101 is shifted towards right, so 1 is left only, and then this 111 from the most significant side will come up here, so that would 111, and then only 1 is remaining, and then this 111 coming from the most significant side, so only 1 is left. So what we are going to do in arithmetic right, if you remember, these 3 bits should be filled by the most significant bit of the original number, which is what? 1. So we will be filling these locations by most significant bit of sign number, which is 1 always. So what is going to be our result? F, and that should be what? That should be B. So, and that should be what? That is the minus 5 in decimal, right? And I can also verify it using that sheet. Okay, before I run this program, let me verify it. Okay, the sheet is what sheet says minus 40 divided by 8 should be minus 5, and look, triple FB, that is the result. So let's see what program calculates for us. We may let this program single step. FFD8 is loaded, which is correct, minus 40 in decimal, 03 which is count in CL register, and FP which is division by 2 power 3, which is minus 5 in decimal. So I hope everything is clear in shift arithmetic, right? Okay, that's it from this lecture. Today we learned about shifting right and shifting left. We learned that when we shift towards light, that means we are dividing by 2 power number of bits, and if we are shifting left, then we are multiplying by 2 power number of bits we are going to shift, and then we can perform these two shifting in two different numbers, signed numbers and unsigned numbers. When we perform these shiftings in signed numbers, then we call them shifting arithmetic, and then and if we are performing in unsigned numbers, then we call them in shifting in logically or logical shift. So that's it from this lecture. If you have got any question, please let me know in online session and we will try to solve those questions. Thank you so much for listening.